Now we will explain about the copying process. The copying process consists of charging, original scanning, image processing, laser exposure scanning, development, transfer guide bias, transfer and separation, fixing, cleaning, and discharge. While charging, the 0.06 millimeter diameter tungsten wire is biased at about -5 kilovolts, and the charger grid is biased at -637 volts. As a result, by applying a charge evenly to the surface of the photosensitive drum, the electric potential of the surface becomes about -600 volts, which is almost the same as the grid voltage. An OPC drum with a diameter of 30 millimeters is used for the drum. In original scanning, the light irradiated to an original is reflected. The reflected light corresponding to the density of the original is projected to a CCD, or charged coupled device, via the mirrors and lens. Then the entire original is scanned by the carriages moving in accordance with the size of the original. A xenon lamp, whose power consumption is about 14.5 watts, is used for exposing the original and is controlled by on-off DC circuits. Pitch in the photosensitive element of the CCD corresponds to scanning track density. The CCD in the DP1600 has 7,450 elements for a resolution of 600 dpi. Since the signal obtained by the CCD is analog, AD conversion converts the analog signal into the digital signal in 256 steps. The image signal converted to digital signals is then sent to the image processing section. In the image processing section, corrections are made, or some editing processes are conducted to provide appropriate image quality. Then the image signals are finally sent to the laser exposure scanning process. In the laser exposure scanning process, the laser diodes are turned either on or off, depending on the image signals. The electric potential of the drum surface where the laser beam is directed gets close to 0 volts, and the potential of the drum surface where the laser beam is not directed remains at -600 volts. As a result, a latent image, which cannot be seen directly by the human eye, is formed on the drum surface. In the development process, the new type dual component development process is adopted. The developer material is composed of carriers whose component is ferrite and magnetic toner whose components are resins and magnetite. The magnetic force of the 12 magnets in the magnetic roller allows the rotating carriers to constantly adhere to the rotating magnetic roller. The toner is mixed in the developer unit and transported onto the magnetic roller. Then the carriers become positively charged and the toner negatively charged by friction on the magnetic roller. However, the carriers and toner are not charged enough by friction. Therefore, a developer bias is applied to them, resulting in the magnetic toner being completely negatively charged. The toner that adheres to the carriers are transported and gently brushed onto the drum surface by the magnetic roller. In the laser exposure scanning process, the electric potential of the drum surface, which is exposed by the laser beam, becomes lower than the developer bias, which is -430 volts. So negatively charged toner adheres to the drum. Since the electric potential of the drum surface, which was not exposed, is more negative than the developer bias, negatively charged toner does not adhere to the drum. When the potential of the drum surface becomes 0 volts, as before, the main charger output comes on, and after it goes off, the developer bias is switched to +150 volts to prevent the adherence of toner to the drum. The toner empty sensor is an oscillatory sensor. It can detect the toner level by monitoring the amplitude waveform of vibrations that vary depending on the remaining quantity of the toner. When the toner level becomes low in the developer unit, the toner is replenished by the toner motor. However, if the toner is not replenished with the toner motor turned on for a specified period of time, the toner empty sensor detects that the toner is running out. Between the transfer process and separation process, the transfer guide bias is applied. When paper is moistened, its resistance is decreased, which lets the electric charge from the transfer charger escape to the metallic roller or transport guide through the paper, causing a transfer problem. To prevent this, a transfer bias of 375 volts is applied to the roller and guide. The transfer bias comes on when the distance from the leading edge of the paper is about 11 millimeters. It goes off when the distance from the trailing edge of paper is about 24 millimeters. This prevents the toner from adhering to the transfer guide from the white part on the drum. In the transfer process, the toner is moved onto the drum to the paper by applying positive high voltage from the back of the paper. Adherence of the paper to the drum varies depending on the transport position of the paper, affecting transferability. To correct this variation and to obtain the best transferability at any position, positive high voltage is output in 2 steps. For the DP2500, the transfer output is applied as shown. In addition, if no paper is present in the transfer process, the transfer output goes off to reduce the amount of ozone generated. In the separation process, the paper adhering to the drum by electrostatic or positive charges applied in the transfer process is electrically neutralized and separated along with the toner from the drum. Paper separation varies with the variable adherence of the paper to the drum and with the transfer output. Therefore, negative voltage is output in 3 steps to obtain the best separation and transferability at any paper position. In the fixing process, heat from the heat roller and the pressure of the rubber roller fix the toner permanently on the paper. The cleaning roller is installed to clear toner and paper dust from the rubber roller. There are separation claws to separate the paper from the heat roller. In the cleaning process, the toner remaining on the drum is scraped off by the main blade and captured by the recovery blade. The collected toner is then stored in a separate compartment from the unused toner in the toner cartridge. Finally, to even out the charge on the drum for the next charging process, the light from the discharge LED array, where 14 or 15 red LEDs with a wavelength of 660 nanometers are arrayed, illuminates the entire drum and discharge is performed. This is the end of the copying process. Also, various controls are performed for high image reproducibility according to the drum rotation counter and drum thermistor. As the drum is used, the electric potential of the drum surface gradually becomes lower. As a countermeasure against this, the charger grid voltage is raised corresponding to the drum rotation counter. For the DP1600, when the drum rotation counter reaches 121,000, which is equal to 27,000 copies in an environmental temperature of 21 degrees Celsius, the charger grid voltage is raised by about 4% from the initial. Along with this, the developer bias is raised by about 1.9%, and the laser power by about 16.8%. By means of the drum thermistor, under an environmental temperature of 9 to 21 degrees Celsius, charger grid voltage is corrected within -2 to -5 volts per 2 degrees Celsius. For the developer bias, correction is made within -3 to -5 volts per 2 degrees Celsius.